Hey there, physical science students. This is Miss Ruark. This would be Vodcast 3.2a because this is the simple machine chart that we need to fill in that will be your reference sheet for simple machines. And then I'll give you more information when you get into class that'll give you some help in identifying difference between first, second, and third class levers. And we'll talk about inclined planes and wedges and why they're different and the sort. So you should have your paper in front of you and we need to fill this in. So to define a first class lever, it's a lever that has a fulcrum that's located between the input force and the output force, or the load. Okay, so the fulcrum is the actual point of pivot, or the point where it moves. Okay, so the mechanical advantage for a first class lever can be equal to 1, greater than 1, or less than 1. And examples of those would be a hammer, a seesaw, scissors, and there's more. Okay, so what I want you to do is you can draw the picture here, and we'll talk about where the points and the forces and all that are in class. A second class lever is going to have an output force in the middle, and the input force in the fulcrum will be on the outside. So the output force is in the middle, input and fulcrum on the outside. The mechanical advantage is always greater than 1, and examples of that would be a wheelbarrow or a bottle top opener. Okay, the third class lever has the input force in the middle with the fulcrum and the output force on the outside. The mechanical advantage for that is going to be less than 1, and examples of that would be hammering a nail or kicking a soccer ball. Okay, an inclined plane has a straight and slanted surface. Okay, so it's a slanted surface, but it's straight. It doesn't have any dips in it. And the longer the incline would be, the longer the slanted surface is, the longer the plane, greater the mechanical advantage. Okay, and an example of that would be a ramp. You guys have all seen those. You've all walked on them. We've talked about them in class. Okay, a wedge is something that people confuse with an inclined plane. A wedge is not an inclined plane. A wedge is different. It's a double inclined plane. So there's two of them put together, and the double inclined plane moves. It doesn't sit still like a ramp would. So this is going to move, and it's going to be used to separate objects. Okay, the longer and the thinner the wedge is, the greater the mechanical advantage. And examples of these would be an axe to cut wood, a knife to cut your meat or your whatever you're cutting. Plows, chisels, these are just examples of some. We can come up with more in class. All right, a screw. A screw is an inclined plane that's actually wrapped in a spiral. Okay, the longer the spiral and the closer the threads are, the greater the mechanical advantage of the screw. Okay, so examples of these without actually saying screw, because yeah, a screw is an example, but other examples would be jar lids, bolts, and soda bottle lids. Anything that has a screw top is a screw. It's a mechanical advantage. It's a machine. Wheel and axle. That's going to be two circular objects of different sizes that are put together. Their mechanical advantage for this is usually greater than 1. And examples of these would be doorknobs, wrenches, Ferris wheels, screwdrivers, bicycle tires, bicycle gears. All of these would be examples of wheel and axle. Even your car, wheel and axle. Pulley or fixed pulley is a wheel with a groove and a cable, and it's usually fixed to one central place. The mechanical advantage for this would be equal to 1, and some examples, but there are many, would be an elevator or flagpole. They have pulleys on them so that you can raise the flag so that you can raise the elevator. All right, and then last but not least, a compound machine is going to be two or more simple machines combined. The more moving parts there are, the greater the mechanical advantage is. An example of that would be a can opener. Can opener is a combination of 3 different simple machines. You have the lever, you have a wheel and axle, and you have a wedge. Okay, all of them put together. Another example of a compound machine would be a Rube Goldmeier, I think it's Rube Goldmeier machine. And it's all sorts of simple machines put together to complete a task, which is usually a very simple task. But you put all these simple machines together and it ends up doing this simple task for you. All right, that's it. Well, make sure you have this filled out and we'll use it in class.